The objective of this video is to identify similar polygons and find missing measures of similar polygons. Could be missing measures of angles or missing measures of sides. Now, looking at these two shapes, you might say that they are similar because they're both rectangles, and you recognize them as such, and you say, oh, they're similar. Well, in regular English terms, that's fine, but in math, we like to be a little more precise about it. So our definition is a little bit pickier than that. Two polygons are considered similar if their corresponding angles are congruent. That means their angles are equal. And the measures of their corresponding sides are proportional. Proportional. You'll remember that from first semester in our class there. Proportional. It generally means that one of them is going to be bigger than the other, but they have the same shape. All right. In models, you would see something like this, where you have triangle ABC and triangle XYZ. And you'll notice that I've got one arch here to show and one arch here to show that this angle and this angle are equal. Two arches here lets me know that those two angles are equal. Three here lets you know that those two angles are equal. So they can tell you that without actually telling you the actual measure of the angle. They can just tell you that they are equal by showing symbols like that. And to show that they're similar, they would have triangle ABC is similar, that single squiggle line is similar to triangle XYZ. In symbols, this would be written as angle A is congruent to. This equal sign, the little squiggle on top, stands for is congruent to angle X. Angle A, congruent to angle X. Angle B, congruent to angle Y. Angle C, congruent to angle Z. And here's the big part here. This is the proportional part. AB, side AB, corresponds to side XY over here. This one has one angle and one arch and two arches. That forms, both of those are connected to this line. The 1 and 2 are connected to this line. 1 and 2 are connected to this line. That makes them corresponding parts. And if you put one over the other, that's going to be equal to the corresponding part here, BC, over its corresponding part here, YZ. So the length of AB over XY is going to be equal to the length of BC over length of YZ, which is also going to be equal to the length of AC over the length of XZ. And that's what we're going to use to find missing lengths. Now, in the textbook, they talk about scale factor, and scale factor is important to understand what the definition of a scale factor is. The scale factor is the ratio of the lengths of two corresponding sides of two similar polygons. That stuff I had on the bottom, the AB over XY, that was the proportions there. That's the scale factor. Corresponding parts are the parts of similar figures that match, quote unquote, match. Now, that's where we come to they're not going to be exactly equal, but they're the same side but on the different figure. Looking at these two triangles, I'm told that they are similar. I need to match up the sides. Well, this side here has a length of 3. It's got the 90-degree angle and the double arch angle connected to it. This one has the 90-degree angle and the double arch connected to it. So this side and this side match. They are corresponding sides. This is opposite of the 90-degree angle. It's the hypotenuse of that triangle. That's going to match up with the hypotenuse of this triangle. This is the remaining leg. It will match up with this leg here. 91 arch, 91 arch, they match up. That's true of any shape, whether it be the triangle or one of these trapezoid type things. Here I have the 90-90. Looks like they took this shape and just kind of like lifted it upright like that and made it a little bit larger. So this side here is going to match up with this side here. This side is going to match with this side. This is going to match with this, and this will match with this. They're not always going to be nicely put together in the same orientation. They may be turned around, flipped around. You have to be able to identify the corresponding parts based on the angle measures they give you and which ones they're connected to. Okay, determine whether the rectangle HJKL is similar to rectangle MNPQ. Explain. Since it does say explain, we should know by now that that means there needs to be a full sentence answer. I've already started the full sentence answer here. It says rectangles HJKL and MNPQ are not, I'm going to have to choose whether they are or are not similar because, and I'll fill in the blank there. That's a good way to answer this type of question using a full sentence. All right, to figure it out, we look at the corresponding parts. Well, the angles here, 90, 90, 90, 90, 90, they're all 90. So this angle matches that one, they all match up angle-wise. So as far as the angles are concerned, these are similar figures. But we also have to check the proportionality here. All right, to do that, we check HJ over MN. This length over this length. 7 over 10. And that fraction there needs to be the same all the way across in order for these two shapes to be proportional. So if we look at JK and put that over NP, we get 3 over 6, which reduces to 1/2. Is 1/2 the same as 7/10? No. That means these two shapes are not proportional. And if I continue down, I'm going to end up having 7/10 and 3/6 here. Although these things are equal and these two are equal, all 4 would have to be equal in order for them to be proportional. All right. You do. Determine whether triangle ABC is similar to triangle XYZ and explain. All right, welcome back. We have these two triangles here, and one of those, this one's got 3, 4, 5 for its sides, and ABC. This one's got a 90-degree angle here. There is no 90-degree angle over here. This angle does match up. 2 arches here, 2 arches here, it does match up. But none of the other angles do. Therefore, these are not similar. They are not similar because their angles are not congruent. Now on this one, the angles are congruent. We have 1 arch, 1 arch, 2 arch, 2 arch, 3 arch, 3 arch. So the angles are congruent. And it looks like they kind of flip this around so that B actually matches up with X, A matches up with Z, and C matches with Y. So when we do the proportions on this one, to check to make sure they are proportional, we're going to do AC is proportional to, well, 1 arch, 3 arch, 1 arch, 3, that's going to be proportional to the 18, which is the YZ. So 24 is to 18. And checking the next one, I do AB. Let's see, AB, which one does that match up with? 1 arch, 2 arch, 1 arch, 2 arch. So that 20 is going to match up with the XZ, the 15. If I reduce this, both of them are divisible by 8. I get 3 over, no, they're not both divisible. They're both divisible by 3. I would get 8 over 6, which is 1 and 1/3. And this also works out to be 1 and 1/3. Put in the calculator, you're going to get 1.3 repeating on both of them. One last one to check to make sure. BC is 16. It's going to match up with a 2 arch, 3 arch. 2 arch, 3 arch is this one, so it's going to match up with the 12, which is the X, Y. And you do that division, you're going to get the 1.3 repeating, so they all do match up. So these two are proportional, and you'd say they are similar because their angles are congruent. So you'd say they are similar because angles are congruent, and their sides are proportional. Full sentences whenever they say explain. All right, finding missing angles, sides. Well, the textbook's going to explain it to you using scale factors. I myself get confused with scale factors. When I look at them, I'm not sure whether I need to put this one on top, that one on top. It gets confusing to me, and I find you're more likely to make mistakes working with scale factors than you are to work with proportions. And I've come up with a little way of memorizing how to work these proportions out so you make less mistakes there. If you think in terms of the fact that whenever you have two similar shapes, one of them is going to be bigger than the other. So when it comes time to set the proportions, if you think in terms of this edge on the small shape matches up with this edge on the big shape, small to big, needs to be equal to this edge on this shape, matches with this one, small to big. Small to big, small to big. You set the proportion like that with the corresponding parts, and you'll be good. You can even set it up big to small, the big side over the small. As long as you're big to small, you're fine there. You can't do small to big to small, setting them equal. That is not correct. Now, you may not be given two pictures like this. You may be given some information about a scale drawing. And if you do scale size to real size equals scale to real, that'll work as well. It's just like big to small or small to big. Original to reduced, if you got an original thing that you need to reduce in size, original to reduce size over original to reduce. As long as you keep it consistent across both sides of the equal sign, you should be able to set up those proportions fairly easily and work with that. All right, finding M and N. Let's find M first. To find M, first I need to make sure the board is not going to fall. To find M, I need to set up a proportion. This shape is bigger than that one. And yeah, the arches are measured here, but we're told, I'm going to tell you, these two are similar, even though I didn't write the arches in here. They're similar. So we got to set the proportions. Well, M is the WX. And that's going to match up with AB. So I would put M over 10, small to big, smaller shape over bigger shape. Let's work with the whole number here. This is going to match up with this side here, 6 to 12. We only have to match it up with one side because those fractions should be equal all the way through. To solve these, remember, go back to last year on that one. To solve, we cross multiply. I get 12M is equal to 60. Cross multiply, set the products equal. Then you're going to divide, and you get M is equal to 5. So I found M. Now, the N, to find N, I would do, let's keep this to the top. Let's do big to small. I'm going to do N over 4.2. This edge over that edge is going to be equal to, let's work with that same 6 and 12, only now I'm going to put it 12 over 6, because big to small. Cross multiply, I get 6n is equal to, and I believe if I do 12 times 4.2, I get 50.4. you divide by 6, and you're going to get n is equal to 8.4. And you can check that in your calculator. All right, best way to learn math is to do math, so find the missing measure. Pause the video and find the missing measure. Welcome back. All right, for this one, we're going to match up, well, we need to find x. X is this edge, that matches with this edge, which we don't have a measurement for, which is going to make this one difficult. Let's scrap the you do on this one. We'll go to class, okay? Thank you. I'll have to erase that.